you may have seen it or have used it or have heard of it. It will be a cool tutorial. Thanks, Danilo. We can get started and just we're just around the room here.
Okay. Is my screen sharing already? Okay, let's try one more time. Is it working?
Yeah, we see it. It's a browser at a browser aspect ratio. And now it looks like a slide.
Okay, perfect. Hi, everyone. How are you guys? Are you enjoying the week? So let's me introduce first. And based inspired by Alex's talk today, I'm going to talk a little bit about myself. So who am I? And in professional terms, I'm a PhD candidate in physical oceanography. So I work with cross-shelf exchanges. But I'm also a graduate research assistant and a data analyst and a scientific consultant called Oraculometeorologia. In English will be Oracle Meteorology. But also I am a Brazilian guy, so speaking another language is very hard. And today I'm achieving a milestone for me, giving a talk in English. I'm also a dog owner. Actually, the dog owns me, so this is this pretty beautiful girl here. And also I'm a rugby athlete, so I'm a person with a lot of faces. So let's start with Xarray right now. Are you guys seeing this Jupyter notebook?
Yes.
Okay. So today I'm going to talk about Xarray, and the title of this presentation is Xarray in 45 minutes, but I think I'm going to take much more less time than this.
Sorry, Dennis. Do you mind zooming a little bit? It's kind of hard to see the fonts.
Yeah, definitely. It's better now?
Like a very narrow vertical. Yeah, that is better. Thank you.
Sorry.
No worries. Thank you.
So
right.
This presentation is mostly copied from the official tutorial from the Xarray documentation. So this is the source link. And I don't know if you guys are still using Twitter, but this is my handle and my GitHub handle if you want to talk with me or follow my work. So, okay. Xarray is kind of, actually, we are going to talk about the Xarray covering the basic aspects of this package. And I hope at the end of today, we can understand a little bit more what is Xarray, there's objects, and what we can do, what we can achieve with this package. So we are going to talk about the main components of the Xarray. So what is dataset, what is data array, dimensions, coordinates, and everything. And this is like a graphic representation of what is an Xarray object. So we have a data set, a lot of variables, coordinates, and dimensions, and we're going to talk about it soon. So the first thing first, how we can work with Xarray, basically importing this package like in this way. So import Xarray as XR. XR is just a very popular convention to use Xarray, but you can give whatever you want to call Xarray. So like OHR, but let's say an XR. Let me run this. Oh. Okay, there is no kernel connected. Okay. So For this tutorial, we're going to use a data set that we can, all of you can download and use very quickly, just using this piece of code here. So we are going to work with the air temperature from data set from, I guess, from the National Center for Environment Prediction. Yeah, that's it. From this source here. But one highlight I have to give this, it is that to use this XR tutorial load data set, we need to have, we need to have some packages installed in our environment. So one of them is the Pooch. So to replicate this tutorial, I recommend to use the Jupyter Hub that the OceanHackWeek organizers provide us, which is what I'm using here. So all packages are already installed and you might not have any problems with this. So let's run this here, and okay, it is working. So we have this data set, we have attributes, variables, coordinates, dimensions, and you're good to go. So what is a data set? I said that we have a data set here, and the only way we know that is a data set is because Python is telling us this. But what is a data set? Basically, it's like a collection of data arrays. And what is a data array? So data array is a container for data. So we have dictionary-like containers of data. And in this container, we have a NumPy array here, so which is our data specifically. And we also have coordinates. So we have the latitude, longitude, and time. And our data is indexed by these coordinates. So we have time, almost 3,000 time steps, latitude, and longitude. And also, one very important thing of Xarray is that we have attributes. So we have metadata associated with our data itself. So we know that our variable here is called air, but this variable also have a long name. So it's like this one here. We can also have the units of this data, also the precision, and a lot of other attributes here, like the source, a description, the range, the spatial range, and the temporal range of this data, and a lot of other stuff. And these attributes are very important because the Xarray is going to use these attributes to do things later. And I'm going to show you some. Also, I'm using this dictionary syntax here to access my data, but we can also use this dot notation. So ds.r, and it's going to show exactly the same thing. Okay. And it's just two ways to do the same thing. So what is a data array? It's like basically is the data with a lot of metadata, like I said. So we have a lot of attributes, which are our metadata. We also have the dimensions and the coordinates. They are also our metadata. So first we have, the first thing here is that our dimensions, the dimensions are named. So we have time as our dimension, we have latitude, we have longitude, instead of just numbers as in NumPy. So let's see what are our dimensions. Yeah, so we have time, lat, long. And these guys here, they are very important because all our data is basically indexed by these dimensions. So if I'm type here, showing the data array one more time. Oh, sorry. So our data is indexed by these dimensions. So we have time, lat, long, And even if I show the format of our data, we still have this time, lat, long dimensions. So it's very important to have named dimensions, and this is very important for Xarray. So moving on, we also have coordinate variables, and the way we can access these coordinates is using the dot coords. So let me run this, and these coordinates are just a container for our coordinate variables. So sometimes we can mix this, thinking that coordinates are dimensions, but they are different, because dimension is just the name, and the coordinates is actually the data associated to these dimensions. So we have, for latitudes, we have this array here. For longitude, we have this another array, and also for the time. So these coordinates holds our information for the coordinates and for the dimensions. We can also extract the coordinates variables using the syntax here. So ds.r.long, and we are going to see that we have data array covering our longitudes from 200 to 313 degrees. And we also, for the coordinates, we also have attributes. So for the longitude, we know that the standard name is longitude, the long name is longitude. We have the units, and we have the axis. And that is just a reason, so we can use this for plot maps or other stuffs later. And we can also extract coordinates using this notation here. Again, it's just two ways to achieve the same information. So I mentioned that coordinates and the data have attributes, but we also have arbitrary attributes. So for our variable here, for the dsr dot attributes, we have, as I showed before, the long name, units, precision, actual range, and everything. And we can also assign others attributes. So we have this cell here, and we are adding a new attribute using this dictionary-like notation, and printing the attributes. We have this guy right here at the end. And if we are check the data array, we are going to see this attribute one more time here on the data set structure. Okay. So let's talk about the data itself. So in the Xarray, what we have actually is that the Xarray is built on top of NumPy arrays. So if I type this here, I'm going to see that actually my air temperature is in a NumPy array, and we can check that what I'm saying is true using this type command from Python. And actually we have this NumPy n-dimensional array, and that's what basically our Xarray have. So what I have here is like we have multiple levels of metadata layers built on top of NumPy array, and one of these layers are dimensions, so time, lat, long, and also we have dimensions metadata. So we have all of these attributes built upon the NumPy. Just to clean the screen. So reviewing, we can think in data arrays as an any-dimensional NumPy array with a bunch of associated metadata, as I mentioned. And data sets, they are a collection of data arrays. So let's say we have the air temperature, but we also might have atmospheric pressure or sea surface temperature, and all those data are indexed by the same dimensions. So just to show you this data set with a lot of data arrays, I'm going to import this this netcdf file here. Let me copy this one. This file is available on the shared folder of the Jupyter Hub. So, okay. We always have problems when you are doing things. Okay. I didn't set the absolute path. Oh. Let's do this the hard way. Okay. So I imported, I opened this data, this netcdf from the ARA5 outputs, the reanalysis, and we have time, lat, and long. We have a lot of time, and we have, I believe, the whole globe here, and we have a lot of variables. So we have the velocity, the two components of wind velocity. We have the SST, we have the pressure, we have the 2 meters air temperature, and all other stuff. So we can check the data by clicking in this guy here. So since it is a very large file, we cannot see this this information, but we can check the metadata associated to this variable. And if I just to show you how we can see the data using this notation, we can access by clicking this icon here, and we have the data. We can check if our values are right. So we have really high temperatures, so we probably have Kelvin units, and we can check the unit, the metadata, the attributes, and yeah, we have Kelvin. Okay, so this is like a data set with a lot of data arrays inside, but we're not going to work with this guy. So you are thinking of why we can use Xarray, and I'm going to show a very simple example of why Xarray is very cool. So this example is just basically plot a single time step from our data set. So let's do this first using only NumPy. And we have to, what we have to do is like, we have to extract our lat. So we have to extract our latitude array, we have to extract our longitude, and we have to extract our data. And by doing this and selecting the first index on the temporal dimension, and the reason I know this is the first position here is the temporal dimensions, because I know the data set, but you have to always keep this in our mind, working this way, and sometimes you can make errors. Okay, so this is just one time step from our air temperature data, and we type the shape here, we can see we have a two-dimensional array. Now we can plot this using the matplotlib package. So we have to provide the longitude data, we have to provide the latitude, and also we have to provide the data itself, so we can plot these things. And okay, so if you're going to take the average the temporal average of this array, we have to use the dot mean. But actually, if I use this axis one, I'm not sure if I'm computing the temporal average, because I don't know what the second axis is. So we know that the first axis is dimensions 0. So okay, we can compute the temporal average here, but we have to always remember that, and sometimes we just cannot know what these dimensions are, what is the right index, right? So why using Xarray is so nice? First, we can extract a single time step, in this case, the first time step, just using this notation. So I'm going to extract from the data set, I'm going to extract the R data array, and I'm going to select only the first time step. And instead of giving the Xarray a number to point which dimension I want to extract, I can use the name, because Xarray knows the names of my dimensions. So doing this, we can extract our first time step, and we can also plot this guy using this dot plot here. So we are selecting the first time step, and we are plotting this first time step. And look how great this figure is, because we have the time here on the title, we have the name of our dimensions, so we have latitude in degrees on the y-axis, we have longitude in degrees on the x-axis, and also we have this color bar, and we have a title for our color bar. And comparing to the Xarray plot, we have nothing, so we have to add those things. So I have to add a title, I have to add an X label, and I hope to work. Okay, so I have to add those things manually, while using the Xarray, he will handle with all those things for us, because he knows that our dimensions names, our attributes, and everything. So I mentioned that the attributes are very important, because when we're plotting the air temperature, is going to take our long name and use this long name as our color bar title. And this is very cool, very cool. Okay, what about computing our temporal average? So we can compute our average, our mean, using this notation here, and we can say what the dimension we want to compute this average. So in this case, it's the temporal average. So just doing this, we are going to have our data array with our latitudes and longitudes. So it is a two-dimensional array. And we also have our coordinates and everything. And we can plug this dot plot here at the end, and we are going to plot those guys. So here there is one problem that I forgot to put on the tutorial, but when we are computing things with the Xarray, we have sometimes we might lose our attributes. So in this case, we don't have any attributes for our air temperature temporal average, but there is a way to handle this. I can't remember right now what this is the way, but definitely there is one. So I guess it's set options, keep attributes. Okay. So okay, so doing this again, we are taking the average, temporal average, and we are still keeping our attributes. So sometimes you need to put this on the top of your code or on your Jupyter notebook to avoid missing the attributes when you're working with the data set. Okay, so I showed to you how to extract some data from using the eye selection, but there is another way to do this using just the dot selection. And this dot selection is just like label-based indexing, so we can extract information from our data set using our coordinates. Either are the coordinates itself, so a specific longitude or a specific time, or using the index position of this information. But first, let's do this using NumPy. So we have to, let's say I want to extract a specific time step. So I have to extract first our time Xarray, and then we probably have to use something like this. I don't know, 2013, May. Okay. I have to convert this string because the time array has a specific format, so I have to pass the right thing. Okay. Oh, 64, not 63. Okay, it worked. So what I'm doing here is using NumPy to look for the index position of a specific date. In this case, is the 1st May of 2013. This position is this 418. And then we can use this to actually extract our data from our temp array, NumPy array. So okay, we have to do all these things here to extract this specific time step using NumPy. But using Xarray, we only need to use this guy here. So ds.cell for selection. We can give the dimension we want to look for the data, and we pass the value. So just doing this, we will find our data. But here. But since I just mentioned the year and the month, the Xarray extracted all data for this particular month. So we have data from 1st May up to 31. So we have the data for all the months, all May. We can also check, just select for a specific day. So our temporal dimension here has just 4 time steps, and we can even look for a particular hour. Okay, and what we have here is just a specific hour of the day, and we have a 2-dimensional data array because we are just extracting this specific time step. We can also use the whole name or the abbreviation of the month. So using this still works. So we have here all the temporal array. Okay, we can also extract a range of this temporal data. So we can extract data from May up to July, and it is still going to work. So we have data here from May up to July. And we can also extract just for 1 year. So we are going to have a lot of data. So I'm not even going to, okay, it's going to work. So we have data from 1st January until 31 December. So this is just an example of how Xarray use its metadata to perform extraction in a way very easily and a very human hearable code, because looking this, we can understand what this code does instead of looking this here. For experienced eyes, we can understand what this code is doing, but it's very much harder than the other example. So we can also extract data using the index position. And I'm going to show this right away, but first, I'm lost here. Okay, it's starting to rain. Okay. I will try to extract this specific longitude from the data set, and it's going to raise an error here. And the reason it's going to raise this error is that we don't have this particular longitude on our data set. So just to show, we have this information here, but looking for it, we have 214 and 242, but we don't have the specific information. And to handle with this problem, we can use this method here called nearest. So the Xarray will look for the nearest position, the nearest longitude to the longitude we're giving. So when we hit the button here, it's going to give this position, the 214 longitude. And you only have a two-dimensional data array because you only have one position in longitude, but you have all these positions in latitude and time. Also, we can use, you can say to the Xarray the tolerance of the radius you might look for the nearest point. So we can check for the Xarray arguments here for the dot cell method. So we have several methods for the extraction. So we have nearest, you have the pad, fill, backfill, and bfill. It's just like different ways to look for the nearest position. But we also have this tolerance argument here. It gives the maximum distance between the location we are given and the data the Xarray might find. So sometimes if we say that we only want a tolerance of 0.005 degrees, it might not look anything here, and it will throw something null. Okay, and we can also extract. We can also use the nearest method using a spatial coverage, so we can extract data between these two longitudes and these two latitudes, and he's going to find something. So we have two longitudes and two latitudes here. So we have a three-dimensional data array. Okay. So it works. But I mentioned earlier that we can also look for information. We can extract information from the data set using the position of the index. So it's very much alike of we perform with NumPy. So in this case, I'm selecting the first time step, the time step, the third, I think it's the longitude, and I think it's the latitude. And we're going to have this single air temperature here. So this is like the NumPy way to look for the information, but the data, the Xarray way is using the dot iCell for I selection, index selection, and we can pass the dimensions name instead of just guessing which dimension it is. So I want the first time step in the dimension time. I want the third latitude. So it's third because in Python, our index start with 0. So it is the third because the first one is 0. And the fourth longitude. So this is going to show us exactly the same information here. So this is our temperature. But it's very much readable to understand this notation here. So just to perform a computation, I'm going to pass for this very quickly because I guess we are ahead of time. So we are going to find the cell average of our data set. So we have, oh, sorry, we can also use the slice method to select the data using the index selection. So I want just the first 10 latitudes, and it's going to give us just the first 10 latitudes. Okay, moving on. What I'm going to do now is just a way to compute the cell average so we can check and do some high-level computations later. So I'm just using some NumPy methods here. So let's run this code. So I have the Earth's average. So we are going to compute the cell average using this equation here. So we know that our data set has a 2.5 degrees resolution. So we're just creating these variables here. So we have this 2.5 degrees, but are converted to radians because we're going to use trigonometrical functions and we need to use radians. And here we are computing the dlat and dlong, which are our delta latitude and delta longitude. So let's run. And let me explain what we are doing here. So for the dlong, first, we are using a lot of information here. So we are computing the cosine from the latitude and converting this latitude from degrees to radian and multiplying this for these constants here. So let's check what is dlong. So this variable here holds is actually a data array with 25 latitudes and with this information here. So it is the same for latitude, but it is based on the longitude dimension. So we have the same information here. And what I'm doing here. So as I mentioned, we computed the cosine of the latitude. So we just checked this before. But this guy here is interesting because what we are doing here is to create a data array similar to our air coordinate, but it is filled with ones. So we have the same dimensions as the longitude data coordinates, but the values are just ones. So we are just doing this to keep the shape of the things to work. Now, so okay, we just checked those guys here. Okay. So note that we have 55 extra array here, and a 25 array here, and we have to multiply those two arrays to find our cell average, like in this notation, actually this notation here. But since they have different sizes, using NumPy, for instance, we cannot do this. We have to use a lot of NumPy classes and methods to solve this. But using Xarray, we just can multiply one by another. So dlong times dlet, and we are going to have something. We are going to have a two-dimensional array because the Xarray understand that we have two different data arrays with two different dimensions. And he's very clever because, okay, I have latitude and longitude and I cannot multiply those things because they are different. But what I can do is to convert this thing in a two-dimensional array by broadcasting this data, basically by expanding our data. So at the end, we are going to have this two-dimensional information here instead of just something else. So just to show how we can do this with NumPy very quickly, we can extract with dlong latitude data, we can extract our dlet data, and we can multiply those two guys here. And okay, he's saying that we cannot broadcast two different shapes, two different matrices with two different shapes. So to solve that, we have to do a few things. I guess new axis and new axis, and I think it's going to work. Okay, so we have to manually broadcast our data using NumPy, but Xarray already performed this for us, so it's very, very, very handy. So moving on. So just to check, since we have this cell area here is like a two-dimensional array, a data array, we can plot this to check if we have valid numbers. So okay, we have small values at the north, higher values near the equator. Okay, that makes sense. And we can perform this division here, and it's going to work because first I am selecting temporal dimension of time step here. So what I have is like a two-dimensional data array, and I'm going to divide this by another two-dimensional array with the same latitudes, with the same longitudes, with the same dimension actually, and this works. So just let me check one thing here. Okay, and this works. So the only reason that this works is because the Xarray understand that the longitude and latitude are the same dimensions, and those matrices, they are aligned between each other, so we can divide these two data arrays. And what the Xarray is going to do is perform is just divide grid cell by grid cell. So since we have two dimensionals similar with the same dimensional array, this is going to work. But let's force an error here just to see how it can the errors you can come up in our daily routine. So what I'm doing here is just I'm creating a cell area Xarray, and I'm using this .copy deep through to create this this copy. and I'm forcing this offset for our latitude, this very small offset for our latitude. And okay, we have this, and now let's try to do the same thing we've done before. So, okay, we don't have any error here, but note that we don't have any latitude. Our latitude is empty, and we don't have any information on our data array, because what happened here is that the Xarray didn't found any alignment between the latitude dimension, so he didn't. It's not an error, but he found anything here. And we can do this running using the multiplication. And why this guy worked here? Oh, okay. Is that because I'm using the right cell area? So okay, this guy works here because we have the dimensions are aligned, and the cell area bed, we have this mismatch, and we cannot we don't have anything to work with. So how we can solve this? There is a few ways to solve this. One way is using this xr.align, but to be honest, I'm not very familiar with this method, but it is probably okay. Yeah, I'm not familiar, and probably I should have jumped at this. But there is a few ways to solve this, and you can use these two links here that are available on the tutorial showing how we can deal with this mismatch between the dimensions and how we can work with broadcasting, and this is highly recommended to work with. Okay, so we don't have much time. So I'm going to pass very quickly for these high-level computations. And if you are familiar with pandas, we probably know these guys here. So the group by, resample, rolling, those guys are very based on pandas. So, okay. So this is our data set, and we have this, we have the temporal dimension, and what we can do is group by this temporal dimension by season. And this is very handy because the Xarray will understand what is summer, winter, spring, and everything else. And he's going to group by our information into these 4 labels here. But for the group by method, we need to pass a statistical method. So in this case, I'm going to use the average, the mean. So we are going to extract the seasonal mean from our data set. And what we have here, that we have 4 seasons. And they are here, and we have our air temperature computed based on the seasons. However, these seasons are in the wrong organization, so we can use the selection to order this label, because the Xarray will give the alphabetically sorted for this dimension, but we can force this just because some people found this annoying. I find this too. And okay. And another high-level computations that we can make with Xarray is that we can resample our data set, and we can use our time dimension to resample this into a monthly frequency and computing our month average. So we are going to have 24 times. It's probably because we have 2 years here. So here, yeah, we have 2013 and we have 2014. So for each month, we have an average. We can do this by weekly. We can do this by in daily frequency. We can do this like every 3 months. I think it's going to work. Yeah, it's working. We can do this every 2 years. Okay. We can do a lot of things with this resample method from the Xarray. Okay, I'm going to. Okay, this guy here is important. So we can also weight our data based on something. So we have our weight here is the cell area that we computed before. So we can do this using this method, but we need to extract the mean, the average. We need to give a statistical method for this computation. And I'm just plotting here. Okay, we're going to extract the longitude and the temporal average on this data set, and we're going to plot this. And what we have is the latitude average weighted by our cell area. So we have the lowest temperatures up north and the highest temperatures near the equator. Okay, Christian asked something. So Christian is asking if it is possible to select any specific hour if our temporal dimension is set right. You can extract, yes, but I think you can only extract for a specific day. I'm not sure if you can extract the same hour from your whole data set, but you can extract at least for a day. I know you can. Okay, moving on. Yeah, there is some ways to extract this. I have worked with a method, but I'm not sure if this method was merged into the Xarray already, but at least I know about a function that performs this kind of extraction that Christian is mentioned in the Slack. But I can look for it later and pass to you. Okay. So just to finish, we have 2 more topics to cover. This first one is the visualization. I mean, we already saw this visualization along the tutorial, but we can do very cool things here. So let's plot our seasonal mean. But instead of selecting a specific season, I want to plot the 4 seasons in just one figure. And we can do this using this method here. And what we have is 4 subplots for each season. We can also, okay, we only have one row with 4 columns, but I want a 2 by 2 format for this figure. We can use the co-wrap and using this argument to plot these 4 figures in a 2 by 2 matrix. And note that we also have our color bar title here. We also have the longitude and latitude and the Xarray handles to share the longitude between the subplots and also the latitude between the subplots, which is very, very handy. Okay. We can also plot the contour. Here I'm just plotted the p-color mesh or the contour, actually p-color mesh, because there is no interpolation here. but you can also plot our contour, and this is going to take some seconds. And okay, we have our contours here. We are saying that we want 20 levels, and we want a color bar. So we have this color bar here. And also we can plot a latitude average. So sorry, a longitude average. So we have these 4 lines showing the longitude average along the latitudes. So we have summer, actually, sorry, winter for the Northern Hemisphere folks, and I have summer here. Okay. And just to finish, sometimes when we have our data set, we apply all those computations and find some interesting, but we don't need to apply this every time. You can access the seasonal mean, for instance. So we can save this as a data set. So we can save this as a net CDF. So it's just like this. You can just type ds.to.netcdf and the name of your file, and it's going to save. And it's going to save this guy here. So just to show you guys. So we have our data set here. And to load this, actually, you can also test with other formats. So we can also save with Xarray. I didn't try this before. Let's see if it's going to work. Apparently it worked. Okay, yes, we have the .zar object here. Okay. And if you want to see what else you can do to save this data set, you can just use this. You can look for it on the documentation, or if you are working with Jupyter or on IPython, you can check those guys here. Okay. And we can load our data set using the open data set as we saw at the very beginning of this tutorial. And okay, we have the same guy because I saved the same guy, the same data set that we opened from the load tutorial data set in the beginning. And we can check if our initial data set is identical to the data set we saved, and yes, they are identical. So it's very important, very interesting to see this thing here happen. So okay, so just to mention that we have the scientific Python ecosystem, and this package integrates within each other. So using the Xarray, we can extract data to a data frame to a pandas data frame. So we're going to have this guy here. So I'm selecting just the first 10 temporal time steps, the first 10 time steps, and saving this into a data frame. And we have this data frame here, and we can work this like a temporal analysis time series. And we can also convert this data frame into an Xarray object. So we are going to have our data set here back. And also we have a lot of alternatives. So we have Dask to work with parallel arrays. We have a lot of packages that I'm not familiar with. So QPipe, Sparse, Pine, and you can work with those guys. But I think we are done with this because we actually passed the time. So thank you for the invitation from the OceanHackWeek guys, and it was very fun. And as I mentioned in the beginning, I consider this like a reached milestone for me. So thank you for the attention.